So the first thing that's required for a synthesis, place, and route flow of the analog on top digital blocks is the technology left and the standard cell left. Also, in addition, are needed the logic gates, the delivery files, which is the time, it has all the timing for the cells, and a process technology file that has different types of layer stacks and capacitance and resistance in order to have Nitro create a spec, which is parasitic, standard parasitic format file. To run the tool, you have several options. You can run synthesis, place, and route. You can run synthesis only or place and route. If you're running synthesis, you need to input all the files you need for synthesis. You may have multiple files, which a top-level file calls the others. It can be in Verilog, VHDL, or both. If you decide that you want to insert scan during the synthesis process, you can do so, and Oasis will give you a basic scan tree. If you have a ScanDef for place and route already, you can import that and place this into the ScanDef entry. The top cell is automatically filled out for you. You need to find your power nets. Sometimes in analog designs, power nets are different than display and digital. And if you decide you need a universal format file, this is the place that you would put it. So we're just about ready to get ready to run the job. One important aspect is you need to find some type of timing. This is a timing-driven place and route system. You can define clocks by entering into the table. You can define from the SDC file as well. We also support multi-corner, multi-mode. So if you have functional and test modes, you can specify an SDC file for different corners for those modes. The floor planning is you can export from layout like we're going to do today because we have a PR boundary and we also have pins and we have our net list. You can have other options for running the floor planning option. Aspect ratio utilization, so you can put that in. You can also choose to specify the block details, just dimensions. And you can also use a def file you may receive from another designer. So today we're just going to export from the layout. You'll notice that the row's site name is filled in with core. It will automatically read the standard cell technology left and determine a row site name. If there's more than one, you'll have several in the pull down. When you run the place and route tool, you most likely will want to share the power rings, the power and ground rails. So you want to automatically flip the rows so that they can abut every other row for power and ground. Row margins are a specification for the distance you want from the core, where all the cells are being placed in the design, to where the power rings or power stripes start. This gives you a little more flexibility. And then you can tell which layer you want. Some people may not want to run on all layers, but I suggest that you do if they're readily available to you. The power plan is very similar. You can specify the power plan. You need to specify the order that you want. You can do rings or you can do stripes. You want to be able to specify the order of the rings, the spacing between the two rings, and the widths of each one. If you want to start it beyond 0, 0, you can actually set some offsets so that the power ring is set at a different location. If you want to put stripes on your design, then you can actually tell it the direction you want, the net order, spacing, widths, and step. The step is the distance between a pair of stripes. So power and ground stripes are placed according to the specification. The step parameter allows you to skip across the chip and start placing another stripe until it's completed. Another option here is to export from layout. If you have a layout like we have now, we don't have a power plan, so we're going to specify the power plan. It will use the floor plan in the layout, but we're specifying the power plan. In addition, each of these, if anything is wrong, for example, here, you can do a question and say stripe parameters, net order cannot be empty. If you go up here and you can't find a file, or you can't find a, this is probably the best example. So here it says stripe parameter, net order cannot be empty. Okay, so the next thing, so we put BDD and BSS, and then we do it again. Let's see, it's going to tell us that we need to add additional information. This is very handy because a lot of times it would just turn red and you didn't know what it was doing. So now it actually tells you exactly what's going on. If you tell you don't want stripes, place this back to that green color. Okay, once you have all the information gathered, you are going to run the tool. You basically had to provide the inputs. You didn't have to read a manual of 1,000 pages, and you're able to place and route your digital block. We are now ready to launch Tanner Digital Implementer. First, TEI gathers all the inputs from the GUI and runs OASIS to synthesize the RTL netlist of the AEC control block to a gate-level Verilog netlist. After synthesis is complete, Nitro is run to place and route the design. During this stage, Nitro creates a new design using the gate-level Verilog netlist, creates a floor plan and power plan based on user specifications, places all the standard cells and IP blocks, and then finishes with detailed routing. Upon completion, Nitro will write a def file of the completed design. LEdit will automatically import the def into an open access database for final integration with the analog on top design. As you can see, we currently have the full design with an LEdit and open access format. This now can be used to validate with Calibre, DRC, and LVS, and then streamed out to GDS2.